Welcome back. In this episode, we are going to attempt to analyze the filling station spatial database by answering some of these questions. So if you have followed along from the first video lesson, at least by now you should have created a file geodatabase on the filling stations in ArcMap, and also you should have created the spatial light database for the filling station in QGIS. So in this very video, we are going to attempt to answer some of these questions by analyzing the spatial database. Okay, before we proceed, let me answer some basic questions that have arisen after the first part of this video series. So there is a question like, what is the essence of creating a spatial database, that is a spatial light database in this case, in the case of QGIS, and a file geodatabase in ArcMap? What is the essence of that spatial database when we can just work with a shapefile? Well, the answer to this kind of question is summarized on this web page. So I'm going to give you the URL to the web page. It is called switchfromshapefile.org. So on this page, you'll find the importance of using a spatial database over a shapefile. There are many limitations to a shapefile. For example, like the size, the maximum size is limited to just 2 gig. The number of characters in the attribute field is limited to 255. And also you have to create one file for a particular feature type. That is, a point feature cannot be combined with a line or polygon feature type, and so on and so forth. So some of those limitations are discussed on this page, and there are recommendations for alternatives using a shapefile. And one of the best recommended alternative over a shapefile is a database. So we use spatial light in QGIS, and then we use a file geodatabase in ArcMap. So just head over to this page. You will find detail to the answer of why we need to create a geodatabase instead of a shapefile for our data. So I know that in our own case here, the data is very small, so we could have just used a shapefile instead of creating a geodatabase. Well, that is one of the advantages of using a file geodatabase or spatial light database over a shapefile. Another common question that has come up is, what is the difference between a file geodatabase and a personal geodatabase? So if you remember, in ArcMap we created personal geodatabase, and we also have file geodatabase. So we also have the ability to connect to an enterprise DB. So in summary, ArcMap supports 3 types of databases. There is the file geodatabase, personal geodatabase, and then enterprise databases. I have a website here where you can compare the differences between them. And with file geodatabase, basically this is meant for Microsoft Access. So when you create file geodatabase, you are actually creating a database in Microsoft Access that you can access with a Microsoft Access package. Then personal geodatabase is strictly accessible on ArcGIS only. you cannot even access it on QGIS or any other GIS environment. So go over this website, you will find some other differences. And also you can go over this particular website to compare different types of databases in ArcMap. So I hope these two will enlighten you on the differences between the databases supported in a ArcGIS environment. So let's move on with the analysis of the questions we have here. So here I have about 9 different questions to analyze using the database. And these questions, they have arisen from curiosity because we have a data of filling stations within a particular region. And then we, out of curiosity, we thought of these useful questions that could be answered using the database and want to analyze it in the GIS environment. Remember that the questions has to be meaningful and it has to be something that the database will provide answer to. For example, you cannot ask the database about the next winner of the Nigerian general election because this data has nothing to do with the Nigerian general election and it cannot even predict who will win the general election. So you need to ask questions that are meaningful for the database to give you meaningful answer. So I'm going to start with the first one. I have created a Microsoft document and this is where I'm going to put in the solution after answering it, and then I will now put a screenshot to the answer right here. So here we have the first one is to find the stations, filling stations within 5 kilometers from the Federal Polytechnic Nasarawa campus gate. So a possible solution to this is to create a point feature at the school gate, then buffer it by 5 kilometers. So we could do this in ArcGIS or QGIS. The procedure, the end result will be the same thing, but the procedure of doing it will slightly be different. So let me use QGIS for this exercise. So I'm going to switch from the Google Map background to a line map background. So this is just a base map from Mapbox API. If you want to have this kind of map, add the base map from the Mapbox API. So here, in order for us to locate the school gate, I'll have to switch from between the two base maps. So here I can scroll and then locate the school gate. If you cannot find it on the map, you can easily go to the site and then pick the coordinate using a GPS device. So for here, I'm familiar with the environment, so it is easier for me to locate the location of the school gate. So the school gate is somewhere here. This is the road that leads into the campus. So from this entrance gate, we need to find the filling station that are 5 kilometers within from the school gate. So let me pick my measure tool. I'll pick the line measure tool and then I will switch to kilometer. Then from the school gate, which is somewhere here, I'll click measure up to a distance of 5 kilometers. So 5 kilometers is a very big, it's a very large distance in this area. So you can see we have a lot of filling stations that fall within the 5 kilometer radius. So to perform these tasks, I'm going to create a point layer here and then buffer that point layer by 5 kilometer or by whatever kilometer I want. So first things first is to create a layer. So I'll go to layer, the layer menu, then create a new shapefile layer. Then I will now navigate to the location where I want to save the file and then save it. Then make sure you choose a point here since we are creating a point feature. So file name, I'm going to click and then navigate to a folder where I'm saving the file. So I'm going to save it inside this folder. I'll call it fn git save. Then it's a point feature. Then the coordinate system, I'm going to use the Nigerian main datum. I'm using a local coordinate system this time around. Then because I need to use a UTM coordinate system because I'm going to measure in kilometer. So then attribute, this is for the new attribute field. This is not important. But if I want to add new attribute field, I just add the name, then click on the add button to add it. So there is no big deal about this. I don't need to have this here. So I click on OK. Then from the point layer, click on toggle editing here and then digitize the point feature. Click on point, then click on where the APN gate is and then digitize it. So here I have created the point. As you can see here, I can toggle editing, save it and then toggle editing. Then I can maybe make the point a little bit bigger. So I double click to open up the property. Then I can now make it, let's say 6. The color, maybe I will make it a brighter color, maybe a very light green. Okay, apply. Okay. So this is where the city gate, the campus gate is. So from the gate, I want to find out the filling station that are 5 kilometers away. So what I will do is to go to the processing toolbox, then search for buffer. So from the buffer, it's under geometry, vector geometry. I'll open up the buffer algorithm. So this is an algorithm that computes buffer area for all features in an input layer using the fixed dynamic distance. So the layer where I want to buffer is the FPN gate. So I select the layer, then the distance is going to be in kilometer, and let's say 5 kilometer. Then all these are optional settings. We can leave it at the default. Then you can save it to a file, or you can save it to a temporary file. But let's save it into a file. So just navigate to the location where you want to save it, and then just create save. Buffer 5 kilometer. So I give it that name and then click on OK. Then I just need to click on run. So if everything was successful, we should see the result of the buffer. So I can now close it and close here. So as you can see, this is the result of the buffer. All this, and make it a hollow, no brush, and increase the thickness. And then maybe change the color of the okay. So you can see that all these are the filling stations that are within 5 kilometers from this school gate. So let me quickly go over it again by creating another one that is maybe 3 kilometers from the school gate. So after creating the FPN gate, the point layer, go back to tools, go to buffer, then select the FPN gate. So in this time around, let me make it 2 kilometers from the school gate. Then all these are optional settings. Then you can save it to a file if you wish. This one I'm going to call it buffer 2 kilometers. Then save, then run, then close. So this is 2 kilometers from the school gate. Let me remove the fill and then increase the size of the outline and let me make it a cyan color. Apply. Okay. So these are the filling stations that are within 2 kilometers. We have 1, 2, 3, 4, 5, 6 that are within the 2 kilometers from the school gate. And these are the ones that are within 5 kilometers from the school gate. So I can easily zoom to the filling stations layer and then let me zoom a little bit like this. Let me remove the background. Let me turn off the 2 kilometer layer and then I will now take screenshot of this into my document. So here I'm taking a screenshot. You can use different tools to take a screenshot of your work. Here I'm using a snip and sketch tool. It comes with Windows 10. So if you search for snip and sketch tool, it comes by default with Windows 10. So you can take screenshot just by clicking on new. And then you highlight the area you want to screenshot. So it will capture the screenshot like this for you. And then you can now take it to your Word document and then you paste it. Right click and then select paste. Or you can press Ctrl V to paste it. So this is 5 kilometers. This is 5 km. Now let me see filling stations. These are filling stations within 5 kilometers from the campus gate. Then I think the second one was those that were 2 kilometers from the school gate. So I'm going to capture the screen of those ones too. And then paste it just above the text. So let me go back to the QGIS environment. Then I can now switch off this. Then on the 2 kilometer layer, then I can now take the screenshots. Also by going back to my snip and sketch tool. You can screenshot the whole screen, or I can just screenshot just the map. But sometimes it's better you screenshot the whole screen so that your supervisor will know that you actually made use of a software and you will see the layers and the tools. So this is 2 kilometers, while this is a 5 kilometer radius from the school gate. So the school gate is in green, while the kilometer for the radius for 2 kilometers is in cyan color, and the radius for 5 kilometers is in red color. I think we can just screenshot the map itself here like this. I think it's a little bit clearer than what we have above. So whichever one works for you is still the same thing, but in most cases you need to prove that you actually made use of a GIS software. and the database layer or database tables are listed on the table of content or the layer panel. So let's move on to the second one. The second one is, what is the average distance between the filling stations? So in this case, we are going to answer the question on the average distance between the filling stations. And precisely, we are going to make use of a tool or a plugin called distance matrix in QGIS. To further explain or clarify what I'm about to do is this. We have the filling stations point layer. So we are trying to find the average distance between all of them. So basically, what we are going to do is to find the distance between filling station 1, 2, 2, 3, 4, 5, 5, 6, 7, 8, and all of them. Then we'll now dividing the sum of the distance by the number of filling stations or the number of interval between the filling stations. And that will give us the average distance we need to travel between the filling stations. As you can see, some filling stations are further apart compared to others. Like for example, these two filling stations are close to each other, but this and this is further apart compared to these two, and so on and so forth. So the tool we are going to use is in the processing toolbox, and it is called the distance matrix. So this is it. When you search for it, you find it, open it. Then the algorithm says this algorithm creates a table containing a distance matrix with distance between all the points in a point layer. So that is exactly what we wanted. So the input point layer is of course the filling stations. So you select the filling stations table from the Spatial Database. Then the input unique ID field. You can use the ID field which is unique. Then the target point layer is the same. The unique ID. Then the output matrix type. There are different ones, but you can use the linear one, the standard, or you can use the standard matrix, whichever one, or you can even use the summary distance matrix. So you can play around with them to find out the one that best suits, but let's use the standard and the distance matrix. And this is optional. That is when you are using the linear option where key will be equal to 0. So the nearest, use only the nearest target point. Then we can save it to a file, or we can save it to a temporary layer. But let me save it to a file. I'll just call it average distance. And click on save. Then click on run. So if everything was successful, it will run and then display the outputs here for us on the layer panel. So if I right click and open up the attribute table, you see that we have the distance matrix of all the point features. So filling station 1 use the unique ID. Filling station 1 to filling station 1, of course, the distance is 0. The average distance is 0. Filling station 1 to filling station 2, this is the average distance. Filling station 1 to filling station 3, this is the average distance. from filling station 3 to filling station, from filling station 1 to filling station 4, and continuously. So let's actually verify this data generated by doing it manually on the screen. So I'm going to close this to create some space. Then what I'm going to do now is to label the point features from the filling station table. So I'm going to right click, open properties, then go to label. Then I'm going to use single label to label the point feature. So I'm going to use the filling station ID, create a buffer around the text, click on apply, and then click on OK. So let's test what we have. So from filling station 1 to filling station 2, from filling station 1 to filling station 2, let's measure the distance and compare what we have on the table. So I pick my distance 2. So I click on filling station 1 and then measure to filling station 2. So the distance says 437 meters. So let's compare it with what we have on the table. So I'll open up the distance matrix table. From filling station 1 to filling station 2 is exactly correct. We'll have a 437.855. If I go back and measure, take my distance 2 and then measure from 1 to 2, you can see we have approximately the same result. So let me compare some other ones. Maybe filling station 10 to from 10 to 11, we have 773 meters. So let me check the attribute table. From filling station 10 to filling station 11, this is it. From filling station 10 to filling station 11, we have 773 meters. So this is the distance matrix table, and you can now take it to your report. You can either screenshot it or you can export it to Excel and then take it into our report document. So here I'm just using screenshot at the moment, and then you can now have the title distance matrix. And let me have it from the beginning like this. Distance matrix, the average distance between filling stations. So you can do some more analysis and extract some meaningful or useful information from this table. If you want, you can write, or you can even demonstrate it on your screen like this. Maybe from filling station 22 to 23 is 380 meters. You can take the screenshot of this and then include it in your report. Maybe something like this. And then you can take it like this and include it in your report. Just like that. So it all depends on the kind of analysis you are trying to run and what exactly you want to communicate to your audience or your supervisor. And you can write the appropriate title for this analysis with the appropriate descriptions. So that is that for the second one. Let's move on to the third one. So in the case of the third question, we are going to analyze the how far the NNPC filling station is from the market. Okay, so here we're going to use just the measure tool to do that. So let's go back to the GIS environment. I'll close this and close the matrix table. Then open up the attribute table. I'll open up the attribute table of the filling stations. So I need to locate the filling station with the name NNPC. So I'll look through the filling station names, and then all I need to do is to query for NNPC mega station. So I've already seen it, but just in case if you cannot see it, what you need to do is to select feature using expression, or you query by attribute if you're using a ACMA. So you type in the expression, you select the field, the column, that's the field name, which is FS name for filling stations, FS for. I'm searching for NNPC mega station. I'll just double click on it to add it here. So the query looks like this. Select filling station name that is equals to NNPC mega station. So if I click on search feature, it will show me the selected feature, number of selected feature here. So I click on search, and then you can see that it has only selected just one feature. So click on close, and then I can click on zoom to selected row, and then the selected row will be zoomed to me. This is the NNPC mega station and on this layer. Okay, this is it here. It is actually number 30 filling station with the ID 30. You can see it is selected in yellow. That is the filling station. If I go back, select the layer and say zoom to selection to zoom to that number 30. So now that I've identified that the filling station, NNPC filling station, is the one with the ID number 30, as you can see here on the attribute table. On the name field, you can see NNPC mega station here. So since I've identified it, I now need to identify the market. So if I switch to Google image, I know that the market is located somewhere here, just before you get to the bridge, even far away from the bridge. This is where the market is located. So the whole of this area is the market. This is the road to oversea. This is oversea junction. So this is where you have the market, and then this other part is the motor park. So, but that is not of much importance to us, because both the park and the market, they are almost in the same place. So, but we can use the center of the market so that at least we'll have a reasonable distance to measure. So what we need to do now is to measure from here down to the filling station, which is somewhere here at number 30, as we have selected or queried earlier. So open up my measure tool. I can switch it to kilometer. I can use the Cartesian distance or ellipsoidal distance. I think Cartesians will be more appropriate here because since it's a short distance. So I'll click from here. Let me go along the road to somewhere here. So this is about 1 kilometer. So from NNPC mega station to the market is approximately 1 kilometer. So that is that. So I can leave my cursor like this and then take the screenshot of the screen, or I can go back. I'll go back here and then take screenshot after 3 seconds so that I can position my screen, my cursor where it is supposed to be before taking the screenshot. So I'll now select and take the screenshot, then go back to my report, and then I will now add it. So this is 1 kilometer. So from NNPC mega station to the market is 1.0077 kilometer. Let me just say distance. Distance from NNPC is 1 kilometer. So as you can see. So that is that. So there could be other ways to do it, but this is just one of the ways you can use to get to answer a question that looks like this. So let's move on to the next question. The next question says, how many filling stations are in Tammah? Okay, so this is going to be relatively simple task. And what we are going to do here is to use the query by location. So we're going to query the attribute table for the location field or location column, QGIS environment. Let's close this window. Then let's zoom to the filling stations layer. So here we are. I can clear the selection. Let me off this layer. So what we need to do now is open up the attribute table. So from the attribute table, I can now query by this attribute field called location. So what we want to find out is the number of how many filling stations are in Tammah. So all I need to do is go to select by expression. The name of the field is location. Where is it? You search for it. Here it is. Double click. Is equals to Tammah. Tammah like this. Make sure you get the spelling correctly. The spelling must be the same as used in the database. Then you can now click on select. So here we can see that the filling stations that are within Tammah. So these are the filling stations that are named Tammah. So they are 6 in number. You can now take your screenshot and then add it in your report while you explain the process of what you did. So this is one. So that is it. So I can now have it as maybe there are 6 filling stations in Tammah. I can even get their names. If I wish to just get the names of the filling stations, I can do that. I think this is a great opportunity for me to demonstrate the capability of a spatial database over a shapefile. So here I just query the attribute table just as normal as we would do in a shapefile. But let's assume we don't want to select the entire column or the entire rows. We are just interested in the names. That's the filling station names, this column of the database. So I can easily do that using the database manager. So since this is a database table, remember this is a spatial database table. So we can easily go to the database manager from the menu, and then I will now write an SQL command. So let me open up the database. So this is the database. I'll connect to it, and then go to query. So here's the table of the database. So I'm just interested in the names, filling station names. I don't want any other column. So what you can do with the shapefile is this. In the shapefile, this is what we did earlier on in the shapefile. So we selected all from the table name. The table name in this case is filling station dash shapefile. It's a wild name, but I hope you understood that. So that is the name. So but look at here, we have a special character here. So I'm not sure if this expression will work, but let's test it by clicking on execute. So click on execute, you can see we have a syntax error here near this symbol. So this character is not allowed when you're writing an SQL expression. So we can easily escape it by using the backtick, by surrounding the name of the table in a backtick code. So the backtick code is usually located on a button near the escape button from the top left corner of your keyboard if you are using the American keyboard. Let me actually go to Google and then get you the image. Backtick on keyboard, so that you will see exactly what I'm talking about. So here's a Google image, and then this is the button to the backtick icon I use. So it is usually from the top left corner under the escape button. So on some other keyboards it may be on a different location, but like this one, it is somewhere here. Let's see where it is here. Okay, this is not clear as far where it is, but on my keyboard it is somewhere just there. So it is called backtick icon. So surround it, use it to enclose your table name if you have special characters within the table name, or else you have errors. So this is what we did. After executing it, you see that we have selected the entire table, and we have just everything as it is in the shapefile. But this is not what we want. What we want is select from the filling station table where we can now use the where clause, where location, this location column, spell it correctly, location, where location is equal to, then you spell Tammah, you surround it in single quote since it's a string. Make sure you spell it correctly. Then now you click on execute. So you can see now we have 6 rows, just the way we have it earlier on. So, but this is selecting everything, all the columns within the database. So, but we are not interested in the columns, in other columns. All we are interested in is just the names. For example, just the names. So instead of using select all, select star, we'll use select, then put in the name of the column. In this case, the name of the column is f underscore name, fs underscore name, fs for filling stations, then name filling stations names. So execute, and you can see now we have just 6 rows with only the filling stations names. So this is one of the power of using a database. You can actually customize what you select or what you query for in a database compared to when you are using just an ordinary shapefile. But I know that this may be beyond the scope of what we are trying to do, but I just feel I should introduce you to SQL expressions. Because later on, whether you like it or not, if you are going to be a successful GIS analyst, you need to be familiar with SQL commands. So you can even combine multiple tables, multiple columns, sorry. Let's look at other important columns that may be useful in this case. So let's assume we want to select, instead of selecting all, we want to select the filling station's name and then the owner's name, and then let's say number of employee. So all these are columns within the database. Number of employee. So click on execute. Okay, there's an error. I think I misspelled one of the. Okay, I have a special character here. Let me remove it and get the correct name for the column. So what we're trying to select are this filling station's name, owner name. Okay, I misspelled the owner name. This is going to be underscore, not dash. If it is a dash, we have to enclose it within the backtick. Then we have the employee, number of employee. I hope the spelling is correct. So execute, and then it will select just the 3 fields for us. Just the 3 fields. So we don't have to select everything. And then we can now export, create new view, or we can export it to another format, another tabular format for further processing. So these are just few capabilities of a database that cannot be achieved using a shapefile. So let me actually copy the command and then keep it here. So this is the SQL command. Let me call it SQL structure query language syntax to select the filling station name, select the filling station names, filling stations, filling station names, owner name, and then number of employees. That are located in Tammah. That are located in Tammah. So this is the SQL command. So let's move on to the next question. The next one says find filling stations that make more than 200,000 naira in daily sales. So this is also a simple one where we are going to query the attribute table. So I can open up the attribute table. Then we have a field that says daily sales. So this is it. And we're interested in finding out the number of filling stations that make more, that's greater than 200,000 naira. So let's do that. Let's query it. So go to select by expression, open up select the field. It says daily sales. So daily sales greater than 200,000. 200,000. So if this expression is correct, when you click on select, you should select all the filling stations that make more than 200,000 in daily sales. So here is the result. We have 19 of them. You can even see them on the map. You can see them on the map. They are selected. They are those that are highlighted in yellow. Let me zoom to there. So all these filling stations that are highlighted in yellow are those that make more than 200,000 in daily sales. And you can begin to look at the special relationship, whether there is a particular pattern or whether the location of the filling stations has something to do with the amount they make in daily sales. So all these are possible analysis. So you can easily take screenshots of this. You can take screenshot of this too. Where is the daily sales? These are the daily sales. These are the names of the owners. So first of all, let me go back to Microsoft Word. I can paste in the query, or yes, or I can type in the query here. The query syntax. It says this, then less than, greater than 200,000. Then I can now paste in the screenshots. Let me take screenshots. You take the screenshots, paste it, and then you have it. So these are the filling stations that make more than 200,000 in daily sale. I think we have 19 of them. 19 filling stations make more than 200,000 in daily sale. So here are they. So the next one too, I think the next ones, other ones are fairly simple ones, and I will leave it for you to actually complete them on your own, because they are basically the same kind of queries. So like the next one says, how many filling stations have more than 10 employees? So it's a simple query. Just go back to here, and then you click on, you just open up your attribute table. You can clear the selection. Then you need to query for what is the name of the field, how many fields should make that more than 10 employees. Okay, so the name of the field is going to be the employee field. So the field is going to be number of employee. What do you call it? This is it, number of employee greater than 10. So select, and then we can see that we have 16. We have 16 filling stations that have more than 10 employees, and they are those ones selected. So other ones too are fairly simple. I think I will leave it for you to complete the rest. And then in case if you have any challenge or you have any problem, you can now reach out to me and then we can address it. So basically this is how to go about carrying out your analysis and completing your report. You make sure that you explain this analysis in details for your presentation. And also, as a final word, if you want to really make this map to prepare for presentation sake, you need to go to create a map layout. It will be something like this. You can call it, let's call it map layout 1. Map layout 1. Then you can now select a paper size by going to properties. Maybe you can use A0 or A3 or whatever paper size you want to use. Then add the map. You add the map somewhere here. So let me switch the background to the one that has the streets, because I think it will be more presentable. So refresh. So this is the map. Let me reduce the scale maybe to 2000. 2000 is to 20,000. 20,000, I think 20,000 is too big. Let's see. So yes, I can even leave this this save. Let me zoom to the extent of this layer. Let me refresh. And then you can see that we now have our map elements appearing gradually. So just prepare the map, and then you can also add the table. Let's see, you can add attribute table. That's attribute table of the database. Now let me switch it to the filling stations. So this is the filling station database. You can work on the font size, work on so many other things, and you can add your not arrow, add your text, add title, add a lot of informations to prepare the map for presentation. So at the end of the day, you have a map that looks something like this. So the map will look like this after the whole design and everything. So this is just merely for presentation sake. I hope you understood the concept and you are able to complete this task. So at this point, I would like to call it a day, and I hope if you have any question or you have any problem, you should be able to reach out to me and I will be glad to assist you. So this is it for this video series. I will see you in the next one. Have a nice day. Bye bye.